Our aim today is box plots and standard deviation, and your homework is Delta Math. So statistics are a matter of perspective. There are many ways in which data tells a story. We can't look at one means of measure and make a conclusion. In this unit, we will analyze statistics through many different lenses, and we use those in order to form a composite of the entire story. So, box and whisker plots. Now, you may have remembered this from middle school. Now, box and whisker, it's a 5-number summary. It has a minimum, a first quartile, a median, third quartile, and maximum. In a box plot, we draw a box from the first quartile to the third. A vertical line goes through the median, and we have the whiskers that extend out to the minimum and maximum. The length of the whiskers indicates the potential outliers and the spread of the data. So, making a box plot. Notice the following example. The first thing that you want to do when you're constructing any box plot is you want to order the data from smallest to largest. And then we want to find the median. Now, what if you have two numbers that are in your median? At this point, we would take the average of those two numbers. And so here we get that the median is 32. And then we have to find the quartiles. So finding the quartiles, you take the median of the lower half and you take the median of the upper half. So for the lower half, the median would be 29. For the upper half, the median is 35. And then you complete the 5-number summary by finding the min and max. And then we plot the points here, and we have our whiskers with our boxes. Now, of note, if your whiskers are close together, or if they're close to the box, that means that your data is closely clustered. However, if your whiskers are long, that would indicate that you have an outlier or outliers. So, standard deviation. It measures the spread or variability in a data distribution. The standard deviation describes the variation in terms of deviation from the mean. A small deviation indicates that the data points tend to be very close to the mean, and a large standard deviation indicates that the data is spread apart over a large range of values. Notice the following sets of numbers. I'll give you a moment. And as you're looking at them, I want you to ask yourself, which has the smallest standard deviation? Well, what's interesting is that all 4 sets of data actually have the same mean and they have the same median. However, the data in set 1 is closely clustered. Therefore, it has the smallest deviation. So, your standard deviation is found by using the following formula, where sigma, that symbol, that is what we call sigma. And this is different from the other sigma that we use for summations. The next one is mu, or x bar. Mu is pronounced like mu in music. N represents the size of the population, and xi, it's a collection sample. Individual x values are coded as x1, x2, x3, etc., etc. So now, using a calculator to find the standard deviation. You don't have to use that formula. Your calculator will do that for you. Please watch the following video as to how to do this on a Texas Instruments calculator. If you do not have a TI-84 Plus, or if your software has not been updated, please listen to some of the prompts that I will give you in these videos. There is a series of them, so if you don't see something the way it looks on your calculator, I might be explaining what's happening at that point. Okay, so we're going to input the data from the last slide. So you want to get your graphing calculator. You want to make sure that your space is cleared as seen here. Okay, so I'm going to hit the Stats button, and you can also see my keystrokes below. And we're going to hit 1 in order to input our values into this table. So we're going to hit 54, enter, 103, enter, 62, enter, 102, enter, 60, enter, 60, enter, 54, enter, and 58, enter. Okay, so now that we have our data set, we're just going to look over it to make sure that we entered in all of the information correctly. And cross-checking, it looks good. So now we're going to hit the Stats button again. I'm going to make this a little wider for you guys. So now we're going to hit the Stats button. And we're going to go over to Calculate. And because we're only comparing one item, we're going to do one bar stat. And in this case, we have no frequency lists. A frequency list is used when you have multiple items or multiple bits of data that are the same. So instead of entering the number 8 11 times, you would just put 8 and then your frequency, how often does it appear? 11 times instead of entering 8 11 times. Okay, so we're going to scroll down to Calculate. We're going to hit Enter. And if you'll notice here, X bar, that is our mean. So our mean here is 69 and an eighth, or 69.125. And our standard deviation for the entire population is 19.45 approximately. And the sample deviation is above, which is 79 approximately. We'll talk about samples at a later time. But if you'll notice too, if you scroll down, it also gives you that 5-number summary that you would use to make a box and whisker plot. So this is how we calculate the standard deviation, also derive the box and whisker plots, and the mean and the sample deviation as well. Okay, so we're going to, so now, what percentage of the data lies within one standard deviation? So as we derived in the first one, when you lie within one standard deviation, you can either be below the mean or above the mean. So we'll take 69.125 plus or minus 19.45. And we get the following. So now we're looking for all of the numbers that would fall between 49.67 and 88.575. And if you look at the data set, there are 6 numbers that fall within one population standard deviation. And so of our sample of 8, that is 75%. Now, this sample standard deviation. Sometimes our data, we only use a sample to represent the whole population because it might be impossible to calculate for everyone. However, we can still estimate the standard deviation, and we will use the following formula. I'm not going to require that you memorize this formula. I'm just informing you as to how we determine this. Okay, so now the standard deviation using a frequency table. Now here we have, for the following set of data, find the number of data within 2 standard deviations of the mean. Notice how we have the data and we have the frequency. We would use a frequency table here in order to minimize how much we have to input. So for example, well, I'll get into that in this video. So now we're done with our previous problem. So how do we clear that and input our frequency table for this problem? So what we're going to do is we're going to hit Stat again, and we're going to hit 1 for edit. And now we're going to go up to L1, and I'm going to hit the word clear, and then I'm going to hit the down arrow, and it clears the table. Another way that you can do this is if you hit stat, sorry. If you hit stat, and then if you hit number 4 there, clear list, that will also clear your list after you hit enter, but I've already done that, so we don't need to. Okay, so I'm going to now clear this portion, and I'm going to show you guys how to input your frequency table. Okay, so we're going to hit stat again, and we're going to hit 1 for edit, and we're going to input the data from our problem. So I'm going to first start with L1 for the first column. Okay, and so now I'm just going to cross-check to make sure I've entered in all of the information. And now in L2, we're going to hit now the arrow, and we're going to start inputting our information for L2. Okay, so now after all of the information has been inputted. So now we're going to hit stat again, and we're going to go over to calculate. Now notice this is still a 1 var stat because even though we have a second column, it's just the frequency of the first. So for example, the number 9 appeared 12 times. So instead of entering in 9 12 times, we just hit 9, next space over, 12. So the calculator knows to compute that. So we're going to hit 1, and we have L1, and then we have a frequency list, and we're going to hit L2, so second L2. Now, of note here, if you do not see this on your calculator, that is fine. Your calculator can still compute these numbers. Instead, what you'll have to do is you'll have to hit, if you don't see the word L1 first, you'll have to hit second 1 for the L1, comma, the comma's next to the x squared, second 2 for L2. That lets your calculator know that you want to compute your frequency list L1, comma, L2. If you can see your frequency list on the calculator, you don't have to do that. So now we're going to go down to calculate. We're going to hit enter. And notice here, we've now been given the mean with the sample deviation along with the population deviation. We're concerned with the population deviation here. And notice that was 65 numbers that we've crunched. Once again, if you had to make a box and whisker, you can see that your 5-number summary is there. So now, okay. So from here, the number with our mean being 11.54 and our standard deviation being 2.85, we're going to find all the numbers that are plus minus 2.85. And so we get the following range of numbers. And when we add those, because we need really any number that's above 8.69 and below 14.39. And so we have these in this portion here that would fall in that category, and we would add the numbers that appear in the frequency list. So that would be 47 numbers, and we get that that is approximately 72%.